So if you're dealing with absolute value inequalities, stay tuned for this lecture and we'll solve some common absolute value inequalities. So for example, first one, we have the absolute value of x plus 1 is equal to 2x minus 1. So we always have to think of an absolute value as with respect to 0. So let's say that's our 0 point, and we have a positive and negative scale. So let's say we have negative 1 and positive 1. So with the absolute value, we can never have a negative interpretation. So if we took the absolute value of positive 1 or just 1, it would be with respect to negative 1 and positive 1. So that means when solving absolute value inequalities, we have to have two cases, two different answers to complete the solution. So based on that concept, the technique to solve problem number 1 is to first just solve it as if it is an ordinary algebraic expression. So we'll just rewrite it as x plus 1 is equal to 2x minus 1. So of course we can bring the 2x to the other side here. So x minus 2x, because we bring the positive 2x over to the other side, and so then it becomes negative 2x. And then we make this equal to this positive 1 is negative 1 minus 1. So when we compute the like terms, we have negative x is equal to negative 2. So then solve for x. So we divide this into negative x is also negative 1x. So we can divide it into negative 1. Both sides into negative 1. So what do we get? We get x is equal to 2. So that would be case number 1. Is x is equal to 2. So feel free to pause that solution set. Now we'll move on to case number 2. So now take the absolute value expression here for the case 2 and just simply multiply negative 1 times that contained quantity expression and make it equal to 2x minus 1. So when we simplify the left side, it is negative x. Then negative 1 times positive 1 is negative 1. Then made equal to 2x minus 1. So we bring the positive 2x from the right side to the left side. So negative x minus 2x is equal to positive 1 minus 1. So this will result in negative 3x is equal to 0. So we divide both sides by negative 3. So this becomes x is equal to 0 divided into negative 3 is 0. So case number 2 is x is equal to 0. Again, feel free to pause the solution set and work it out for yourself thus gaining experience, practice, and mastery. So we'll write the final answer for problem number 1 as x is equal to 2 and x is equal to 0. So that's the final answer for problem number 1. Now to tackle problem number 2 is we really need to isolate the absolute value by itself. So we can rewrite this as 2x minus 3, and like we have an equal sign, we also could have a greater than or less than or greater than equal to, less than or equal to, but focus on this as if it's an equal sign. So just put this greater than symbol here, and now the 3x goes to the other side, negative 3x goes to the other side, so it's positive 3x plus 1. So there's a few tricks to solve this one. So we can go ahead and just solve it as if it is a normal algebraic equation. So positive 3x comes to the other side, so this is 2x minus 3x. And then we bring the negative 3 over to the other side, so that's positive 3 plus 1. So compute. We're left with negative x is greater than 4, but because we're dealing with the absolute value function, we can just simply reverse the sign and the equality, so we get x is then less than negative 4. So that is a technique to just train yourself in equal and opposite, i.e. polarity. And so you quickly solve the first solution as x is less than negative 4. So this will be case number 1. So now to solve for case number 2, simply contain the absolute value. In this case it's 2x minus 3, but contain it in parentheses and then just multiply minus 1 times the quantity. So again, we isolate this. So positive 3x goes on the other side. We're moving this equality here. So when we work out the left side, this is minus 2x. So minus 1 times minus 3 is plus 3. It's greater than 3x plus 1. So now if we bring the positive 3x to the left side, this becomes minus 2x minus 3x is greater than negative 3 plus 1. So this becomes minus 5x is greater than minus 2. So divide both sides by minus 5. And then what do we get? We get x is greater than 2/5, but then we have to change the polarity or the sign, so we have x is less than 2/5. So that becomes case number 2. X is less than 2/5. Again, feel free to pause the solution for problem number 2 and work it out, gain practice and mastery. So we'll enter the final answer for problem 2 as x is less than -4 and x is less than 2/5. So with enough practice, you'll be mastering absolute value inequalities, going from it being difficult to being easy. Thank you for watching this lecture, and have a great day.